and then I download it to my computer, and then I make a YouTube of it. It's a bit of a hassle, but I found that I think the students were happy with the ability to have that done. Okay, so I'm going to go do this problem. Then I'm going to ask for anybody to give me comments. And if everybody's happy with these type of examples, I'll do another example that's a little bit more difficult. Today is sort of a testing situation to see where we actually can start. Actual start class will probably be on Tuesday, where new material will be taught. Okay, so I'm assuming that you know how to solve an equation. This is what's called a two-step equation because you have not only numbers on both sides, you have variables on both sides. And you have to remember what an equation is. This equal sign is really sort of like a balance. You're balancing two sides. And the equal says there, it's like if you had a scale with things on both sides of your scale, and they actually exactly balance. Now, the whole point in solving the equation is really a statement of two things being equal. And what we're trying to find in an equation is the value that we have to assign to the variable. In this case, it's x, which is our most common variable used. What number should we assign to x to make this a true statement? To make it true that when you multiply that number by 7 and add 5 to it, you'll get exactly the same thing as when you multiply that number by 2 and add 30 to it. And the way we solve an equation is to maintain our balance by whatever we do to one side of the equation, we have to do the exact same thing to the other side, so that if we, let's say, take something away from one side, we take the same amount from the other side so that my balance remains. Now, when I'm doing an equation, what I usually try to work with first is the x's. I'm going to try to get the variables all to one side. Now, I usually try to get the variables to the left side, but it doesn't have to be. You can get the variable to whichever side you want. But let's say I want to get all the variables to the left side. That means what I want to get rid of is this 2x over here. Now, how do I get rid of the 2x? I always do the opposite operation. So I look at what the sign is in front of it. If there's no sign, it's understood to be positive. So this is a positive 2x. To get rid of a positive 2x, I've got to add a negative 2x. I have to do minus 2x to both sides. Why do I have to do it to both sides? Because I know I want to get rid of it over here, but whatever I do on this side, I've got to do on this side to maintain my balance. Then I do 7x minus 2x. Now, I am assuming that everybody knows how to deal with positive and negative integers with what we call sign numbers. If you have difficulty with adding, subtracting, multiplying, dividing, you are totally allowed to use a calculator. In fact, a calculator is encouraged in this course. Now, you do not need a fancy graphing calculator for this course. What you need for this course is a two-line, and I'll write this, a two-line scientific calculator. And if you looked on Blackboard, you saw that that was one of the first things I said. Try to get a two-line scientific calculator as soon as possible. Again, let me finish this problem, then I'll talk about the calculator. Okay, so here we're doing 7x minus 2x. Of course, that's giving us 5x. The 5, I didn't subtract anything from it, so I just bring it down. Now what happens with the 2x minus the 2x, it cancels out. So over here, I just bring down the 30. And now I have all the variables to one side. I want to bring the plain numbers, the numbers without any variables, to the other side. So I want to get rid of this 5 from this side. So I'm going to subtract 5 because if it's a positive 5, I do the opposite side of the minus 5. And that gives me 5x over here. And now the 5 minus 5 cancels out, leaves me 0, so I don't even have to put that in. And 30 minus 5 gives me 25. And my last, so here all I've done was add and subtract the same thing to both sides, so I've maintained my balance. I now have what 5x is, and I don't want to know what 5x is. I want to know what x is, which is really 1x. So I have to divide both sides by 5. And that gives me as my final answer, x equals 5. And as I said, a couple people did put that answer in the chat. Is there anybody who has a question as to how that was done? Okay, let's just make 2 comments. Number 1, this is an equation. You can check the equation. You can check to see if your answer is correct. Don't want my board to fall down. By going to my original equation, and wherever I have an x, put it equal to 5, replace it by 5. So this will be 7 times 5 plus 5 equals 2 times 5, because my x we now just said is 5, plus 30. Now 7 times 5 plus 5 is 35 plus 5, which gives me a total of 40 on the left side. On the right side, we do 2 times 5, which is 10 plus 30, which gives me 40 as well. Once I get the exact same number, and it doesn't matter what that number is, once we get the exact same number on both sides of our equation, we know that we have solved this correctly. Again, what have we done? We've taken this original equation, which an equation is a conditional statement. It's saying 7x plus 5 equals 2x plus 30. In what condition? When will that be true? When we solve it, we get x equal to 5. That's what this is telling us. That it's telling us that it's telling us, by solving the equation, it's telling us what value we should put for the variable in order to make this a true statement. And the check proves that it is indeed a true statement. Are we ready to go on to the next step? Okay.
Yeah.
Yes.
Everybody okay? Is there anybody who feels they'd like to do more than this?
Yeah, okay.
Everybody's okay with this?
Yeah.
Yeah.
Great. Okay.
Yeah.
Okay, so I'm going to give you something that's a little bit harder. Again, remember, this is testing. We're just trying to see where we really can start this course. Okay. Okay, so while you're doing this next problem, I'm going to take attendance. Your attendance is not, I do not give an attendance mark, but I will take attendance at each class because it's important for me to see who is participating in class. So, as I said, obviously there are going to be times when you can't. If you know you're going to be out, you might want to email me or let me know that you're going to be out. And again, you could always look at the recording of the class. Okay, so here's the next question I'd like to do. Actually, you might have seen this sheet is what's called homework for 136. I'm not assigning it as homework, but it's basically the type of problems that you're going to see. We're going to do a lot of it in class, the type of problems you would see on a test or a midterm or a final on the first chapter that we are covering, which is not only solving equations, but solving inequalities, etc. So this question is actually question number 2 on that page. As I said, we're basically going to be working these questions in class. Eventually, I will send you an answer key for it so that if you want to practice it some more. Okay, I'll read you the problem. It's -14 plus 5t equals 7 parentheses, open parentheses, t minus 2, close parentheses, plus 2t. So this is a case in which you're going to have to remove parentheses and solve the equation. Okay, so I'm going to pause the recording right now. I'm going to give you time let's go back to this problem. I'm going to again pin my video. Okay, so here we are. Before I finish this or work this out, I want to make a comment about that I said before about using a calculator. The type of calculator you can use in this class is something called a 2-line scientific calculator. You are not to use a graphing calculator. You are to use a regular scientific calculator, and a 2-line is the type that you will find is the most conducive to an easy experience using a calculator. Now, what can we expect the calculator to do? Well, first of all, a scientific calculator has a button, most of them looking something like this, which is a positive and negative button. In other words, you can put in positive numbers, you can put in negative numbers. So that is number 1. A calculator, if you have problems doing adding, subtracting, multiplying, dividing integers or fractions or decimals that are signed numbers, your calculator will do it for you. And I suggest you get used to using the calculator as early in the course as possible. Right now, it is sort of optional. A lot of the work we're going to be doing will not require a calculator, but it will make life simpler. Towards the end of the term, we're going to be touching on topics like trigonometry and exponential functions and logarithmic functions. This might sound like total Greek to what I'm saying now, but by the end of the term, we're going to be doing things that not are that make the calculator not only optional but absolutely necessary. So I suggest you get the calculator now. Now, this type of calculator should not cost more than $20. Probably now at the beginning of the term, you might even be able to get one for in the $10 to $15 range. It's not an expensive item. So that is an absolute necessity for this course. If you buy a calculator, not sure whether it is the appropriate calculator for this course, don't open the box. Just bring it to class and show me, open up your video and show me what you got. And if that's, I'll tell you if that's appropriate or not. A two-line scientific calculator is so user-friendly that you can just stick things in the way they come up in class and it'll come up with the right answers, even if they're very difficult calculations. Again, you are going to need a calculator by the end of the term. Get it early so you get used to using it. If you already have a calculator that you've used in previous class or in high school or whatever, bring it to me, let me see it, let me take a look at it, or you can send me a picture of it and say, is this the right thing? And I will let you know if I want you to use that type of calculator or not. I'm not giving you a specific company that you have to buy, but I do want it to be a two-line scientific calculator. Now, what a two-line calculator means is that if you're looking at the screen, and let's say you want to do 2 plus 3, you'll type in 2, you'll type in your plus, you'll type in your 3, and over here is something like an enter button or equal button. You press your enter and it'll give you the answer on the second line. That's why it's called a two-line calculator, because what it allows you to do is to see the problem and then see the answer. A regular one-line calculator, you keep putting things in and you only see the final thing that you put in. That's why a two-line scientific calculator, it might be a little bit more expensive than the regular calculator, but it's maybe $2 more. It's not a lot more. And it is so much easier to use. Okay, so let's see if we can solve this problem. Okay, I'm still going to be doing the solving. Today I am, erase part of this, sorry. I hope that was the problem. Okay. And let's see if we go through the steps, see what answer we got. So I saw a variety of answers. Let's see which one is correct. So when we have a equation where there is a parentheses, what we first want to do is remove the parentheses. Now, when you have a parentheses and a number in front of it, what it's telling you is that you want to take this whole thing, 2t minus 2, and multiply by 7. It's called using the distributive property. Thank you, Ashley. Perfect. So, and that's always going to be your first step When you see a long, complicated example like this, and the first thing you want to do is try to remove the parentheses. Now, one little hint. If there's no number directly in front of the parentheses, if it's just if there's a sign in front of it, but there's not a number attached, it's as if the number attached is number 1. That's like anything. If I just give you a letter like X, it's understood to mean 1x. So if I give you a parentheses and there's no number in front of it, it means that there's a number 1 there. And when we'll see that, we will actually pencil in a number 1 to remind us that no number doesn't mean there is no number there. It's understood to be 1. It's not 0, it's understood to be 1. Okay, so what I do in this case is I want to get to the place, I'm going to leave everything alone and just deal with the parentheses. So I'm going to leave this as negative 14 plus 5t, because there's no parentheses here, equal, and now I come to my parentheses. I have 7 parentheses, t minus 2. That's going to give me 7t minus 4t. Remember, with a distributive property, you have to multiply each item in the parentheses by the number that's outside. And then just bring this 2t down. So the only thing we did was remove the parentheses. So now we have an equation that has no parentheses. So the next step that we have to look for is we want to deal with each side separately and make sure all we have is a number and a variable. And so I look at this side, and I have a plain number, a negative 14, and a variable plus 5t. When I go to the second side, I have a 7t and another variable, a 2t. I have 2 places where I see variables. So what I want to do is combine the like terms. So I'm not moving anything from one side to the other. All I'm doing is looking at each side separately and combine the like terms. Now, somebody actually told me I should do that. That's Khadija. Thank you. That is perfectly correct. So what we're going to do, I'm going to leave this side alone, the negative 14 plus the 5t. And over here, I'm going to combine the like terms. Now, what are the like terms? The 7t and the 2t. I totally ignore this negative 14 in the middle because that doesn't have any t's attached to it. So how much is 7t plus 2t? Remember, I only look at the sign that's immediately preceding the term. So this has no sign, it means it's positive 7t, and this is a positive 2t. So when I combine them, how much am I going to get?
9t.
Right. And this is minus 4t. Okay, so we're now at the place where we were really with that first problem, where on each side we have a number and a letter, a number and a letter. And again, we want to keep this balanced. Now we want to bring all the variables to one side and all the numbers to the other side. Now, I first look at the variables. I have a 5t over here and a 9t over here. What should I do? Should I get rid of the 5t or should I get rid of the 9t?
Well, I got rid of 5t.
Okay, so usually it's easier to get rid of the smaller one, but it doesn't make a difference. If you go across the other way, it'll work just as easily. So you want to get rid of this 5t, so I'm going to subtract 5t from both sides. I know I have to do minus because this is a positive 5t. And of course, if I do it to one side of the equation, I've got to do it to the other side. Of course, I put it underneath the t because I have to combine the like terms. So what's that going to leave me? Over here, I'm going to be left with negative 14. This gets canceled out. Then I have a 9t minus a 5t, which 9 minus 5 is 4t, minus 4t. Now, once I've taken care of the variables, and I have the variable on one side, then I have to get all the numbers to the other side, and I have to get it to the other side. So since I have the t on the left side, no, on the right side in this case, I've got to get this negative 14 to the other side. So this has a minus in front of it, so to get rid of it, I have to do positive 14. I'm always doing the opposite operation. Now I combine the like terms. Negative 14 plus 14 actually gives me 0. And over here, I'm left with 4t. And this cancels out. And my final step would be to divide by the coefficient of the t, the number in front of the t, which is 4. And that'll leave me 0 divided by 4. Now, how much is 0 divided by any number?
Always 0.
That always gives us 0. So it turns out my final answer is t equals 0. And I do see that several people did get that answer. But those people who didn't get that answer, can you see where you made your error?
Yes, I did.
Okay. Does anybody have a question about this? Okay, let's try.
Professor, I'm sorry, Professor. Can you show us another way to do it? You said there was 2 ways.
You want me to do it by what we call the transposition method?
Yes, ma'am.
Okay. So I'm going to go, is everybody okay if I erase this now?
Yes.
No. Okay. But I'm not erasing the whole thing. I'm going back to over here. In any case, your original step, the original step would be to remove the parentheses by using the distributive property and multiplying everything inside the parentheses by the 7. So we're at this stage. Are you okay with that? Who is it who asked me that question, by the way?
Yakima. I'm
Yes,
sorry. Yes,
okay.
I'm okay with that.
You're okay. Okay. So the transposition method means you're going to move things from one side of the equation to the other by changing the sign. So if I want to do that, what I'm going to try and do is get all the variables on the left side and all the numbers, the plain numbers on the right side. And I'm going to do that right here. So leaving my equal sign where it is, and I'm taking each number. This says negative 14. Negative 14, but remember, on this side, on this left side, I only want to have things with variables next to them. So I don't want this negative 14 over here. So I want to bring it to the other side. When you transpose something from one side of the equation to the other, you must change its sign. So bringing this to the other side will make this a positive 14. And I'll even put a plus in front of it. So if I wrote just plain 14, you would realize that is a positive 14. The next thing I see is my 5t. Now, I don't want to move that 5t because I said I want to leave all the variables on the left side. So I'm leaving that 5t. I don't change its sign because it's already, I'm not moving it. I only change the signs of those things that I move. Okay, that took care of everything that was on the left side. I now go to the right side. Now this is a 17, but I don't want it on the right side. I want this on the left side because I needed all the variables on the left side. So I have to bring the 17 to the other side. What is the sign of the 17? It's obviously positive
Negative.
because it doesn't have any sign. So when I move it,
Really?
it's going to become negative 17. This negative 14 doesn't have any variable. So I'm going to leave it right where it is, which means I don't change its sign. And finally, the 2t, I want that to be on the left side because I'm bringing all the variables to the left side. So there, since this is a positive 2t, on the left side, it's going to become a negative 2t. So what I've accomplished at this point is to get all the variables to one side and all the numbers to the other side. I now combine the like terms. Now it's really easy to combine the like terms because I just have to combine the coefficients, the numbers in front of the variable. So this is a 5 and a negative 7. Again, if you're not good at doing that, you could always take out your calculator and do 5 minus 7 minus 2, because that's the next thing we do, equal. You can do it right on your calculator and it'll give you the right answer. But we can do it without using a calculator. 5 and negative 7 is negative 2. And
Mhm.
negative 2 and negative 2 is negative 4. So this becomes negative 4t. On the other side, I have a positive 14 and a negative 14. Obviously, that gives me just 0. And my final step is to divide by the coefficient of the variable, which is the negative 4. And that gives me t on the left side. And 0 divided by any number, doesn't matter what you're dividing by, you 0 in the numerator, then 0 on the top. As long as it's not a 0 on the bottom, not in the denominator, is 0. And again, we got the same exact answer equal to 0. Did you like that method better?
Yes.
Yes, Professor.
Okay. I am used to doing it the other way, but by consensus of opinion, do you want me to do all the equations this way? Or should I vary it? Sometimes one way, sometimes the other way. Does that make more sense?
Vary it, please.
Yeah.
Okay.
Yeah, it would be better.
Okay. Okay. So it's now 11:20. Instead of going any further, I'm going to stop class now. I'm going to stop